So this video is going to go through question 3 of the 2022 Junior Cycle paper. As shown below is a 3D model of an action camera. Also shown is a drawing of the LCD panel on the back surface of the camera, which displays the power level, Bluetooth and Wi-Fi connection. Part A, the outline of the power display is shown below. Shade the display to show the power level is at 80%. So the first thing we're going to do is we're going to count out the number of boxes we have. So we have 1, 2, 3, 4, 5. So what we do first of all is we take 100%, which is our total, and divide it by 5, which is the number we have. So each box is worth 20%. We want to colour in up to 80. So if we have 20, 40, 60, 80, that means we're going to colour in the first 4. So I'm just going to use a colour there to show that. For part B then, it tells us the camera has Wi-Fi connectivity for uploading videos. The drawing across shows a logo for a wireless connection. Divide the line AB into 5 equal parts and complete the drawing of the wireless logo below. Show all constructions clearly. So this is from first year, and we know that for dividing the line into a number of equal parts, we take a line out at a random angle from one end. So for example like that there, and we step out 5 equal distances. So what I could do is I go out say 10, 20, 30, 40, 50. To make sure I step out the right number in the exam, I would label them to make sure I went out 5. The last one connects to the opposite end of the line, and then we use sliding set squares. So what I'll do is I'll zoom out so you can see it, or just move this across. I have my second set square lined up there, so I can slide across this way. So I'm going parallel there at 4, 3, 2 and 1. All to do then is take the radius of each one around. Like that there. For part C then, I'm told the camera has Bluetooth connectivity to enable it to connect to other devices. Shown on the right is the outline drawing of the Bluetooth symbol based on a regular hexagon. Complete the drawing of the Bluetooth symbol below. So you can see the hexagon is standing up on a point. Now I said to you, if you ever don't like seeing the hexagon on its point and prefer to see it where it's sitting flat, what you can do is turn your page around, which is what I'm going to do because most of you prefer doing it that way. So I'm just going to pause this for a sec and have the page turned around. Now the page is turned around, you can see that the hexagon is the way we usually like to see it. So we know for a hexagon, it fits inside a circle 360 degrees. We have 1, 2, 3, 4, 5, 6 sides in a hexagon. 6 goes into 360 60 times, so 60 degrees are our outside angles. And you'll see there when I go to use set square, you can see I have 60 degrees there. All I have to now is draw my base. We know that all polygons have the same length sides, so I just take the length of PQ, mark it there, go out 60 degrees this way, take that same distance again, go 60 degrees back the other way, and the same again here. So I just need to move the camera back a bit to fit the set square there. And then we take our distance here and here. Then we the exact same height. and now I have my hexagon drawn in. All I have to then is copy the logo below the way it is there, heavy. So these two corners connect together, heavy all the way. The one's going straight across, they go heavy there. These two are connected together, heavy like that. And then P to Q is heavy there, and then this edge is heavy there. So I'm just going to pause the video again and turn the page back around to the way it was for part D then. Now for part D, it says as shown on the right is the action camera mounted on a tripod. A tripod is based on a triangular based pyramid. Shown below is the outline elevation plan of a similar tripod. Part 1, complete the indexing of the elevation from the plan, and then part 2, find the true length of the leg OA. So what they want us to do is find point A in elevation, and very simply, if we follow A up, A goes to that point there. C is on the ground as well, so we follow C up, is there. O is on the same line, but it's the top up here, and then B is this corner here, we follow it up, and that's it labelled there. For part 2 then, find the true length of the leg OA. So this is something that we looked at before when we were looking at the door, and if we rotate the door around, how we see a true shape of it. We're going to do the exact same method here to find the true length. So if we imagine O being our hinge point, I'm going to take a line straight across, because we know that a line parallel to the XY line in plan is going to appear as a true length in elevation. So what I want to do now is take the length of OA in plan and rotate it around. So I'm taking that and turning it around so that it's parallel with the XY line. I take A up in its new position up to here, and I connect it back to O. That now gives me the true length of OA. So what I'm going to do for part E, which is drawing the camera, I'm going to record that as a separate video. So hopefully this video helps anybody stuck on any of the 4 parts here.